Hello, Dr. Noor Fanisa. I'm Kalevani Rajaram from Group 2, Section 4. Today we are going to present about our group project for the subject structure design. These are my group members along with their beam designs. So first of all, myself, I'm Kalevani Rajaram. For simply supported beam, I took first floor, F2 to 4, I mean span. For continuous, I took A span 1 to 4 for the first floor. And then Noor Airil, Khairul Najwa, Mohammad Nazrin, Amirul Danish, and Ahmad Marwan were designed their respective beam designs. For content part, we have include introduction, layout, which is architectural layout, and then engineering layout. We have included in slide, and one simply supported beam design and one continuous beam design. The entire design, I mean, calculation all. We picked one example and summary and conclusion. In introduction part, so I'm gonna explain about what is all about the project, structure design project, and then what calculation we have included into the calculation, which is for design the beam. So first of all, starting from structural design is the analysis of a structure, stability, strength, and rigidity to create a structure that can resist all applied loads for its intended life. It categorized into the characteristic permanent action GK and characteristic variable action, it's called QK. Our group used to use the plan from DAC properties Sandhya and Bhatt, analyzing the design one simply supported beam and one continuous beam for each member. We had calculated the shear force bending moment of the particular beam and determined of the reinforcement is the most suitable, which one is most suitable for the beam. Finally, we had calculate the deflection of the beam and cracking span of the building and make sure the value are qualified. This is the structural layout we are get from the AC properties. There are two floors, which is one ground floor and first floor. So we design the beam based on this plan. This one is engineering layout for the ground floor plan. We have refer the architectural layout from the AC properties and sketch this drawing through AutoCAD. So in ground floor, there is a bedroom, one bathroom, laundry area, kitchen area, living room, and then staircase. For the first floor, there is a 3 bedroom, 3 bathroom, one mini living room, and then of course, first floor always contain a balcony. So this plan also have a balcony in first floor, which is attached for bedroom 1. And then we have followed the measurements, how many spans, and then the columns, all we are referred to the DAC properties architecture plan, and then we come up with the engineering layout. We have sketched this through the AutoCAD.
Assalamualaikum. My name is Noor Aidin bin Nazlan, and now we're going to explain about split spotted beam that we have designed in this assignment. First is the beam on F/2-4 on the first floor. Secondly is the A/1-3 on the first floor. Thirdly is the beam on B/1-3 on the first floor. The fourth one is the beam on E/1-3 on the first floor. And finally is the beam on F/24 on the ground floor. Next, let's move on to the designing and calculation process. One of the important parameters that we need to determine in designing a beam is the action on the beam itself. So we have chosen the beam F/24, which is located on the first floor. As you can see here, the distribution action from slab to the beam is 1.1, which is less than 2. That made it a two-way slab. Next, we need to determine the characteristic permanent action and the characteristic variable action in order to determine the total design action on the beam. And we have able to determine it on this beam, which is 23.79 kilonewton per meter. So that one of the other important element that we need to determine is the design bending moment, which is the 6.43 kilonewton meter. After that, other element that we need to determine is the K value, the K bell value, the Z value, the X, the ratio D prime per X, and also the FSC value. And then we can move on to one of the most crucial part in designing a beam, which is the area of compression for the steel reinforcement. For this beam, we have decided that the area of compression steel that we need to have is 97.47 millimeter square, which based on from Eurocode, we can try to use the reinforcement 3HA, which is 151 millimeter square in area.
Reinforcement. The tensile steel calculation is the required area tension steel AS is calculating uh, by using the standard formula based on the beam parameters yieldings, and it's equals to 449.04 millimeter square. Then we have to choose in the reinforcement is 3H16 bars providing 603 millimeter square, which meets the requirements. Then we have to determine the minimum and maximum reinforcement. For the AS minimum is equals to 46.61 millimeter square, and AS max is equals to 1600 millimeter square. And then we have to select the reinforcement falls within these limits. And the next step, we have to determine the shear reinforcement. For the design shear force, VED is equals to 41.68 kilonewton, and for concrete capacity is calculated to check the adequacy. For the final strut angle is 29 degree, and after that I will move on for the longitudinal reinforcement. The additional steel AS is required longitudinal reinforcement is 51.63 millimeters. Ensure the structure adequacy. For the deflection, the tension reinforcement ratio P equals to 0.003 within the acceptable limits. For the structure factor K is equals to 1, showing compliance with the deflection criteria. Then I will move on for the deflection and cracking check. For the deflection check, the allowable span to effective depth ratio L divided by D allowed is equals to 17, and for actual span to effective depth ratio L divided by D actual equals to 14.6. Since the L divided by D actual is bigger than L divided by D allow, the deflection is acceptable. For the cracking check, the limiting crack with Vmax is equal to 0.5 millimeter. The steel stress Fs is calculate as 216.8 Newton millimeter square, and the maximum bar spacing allows 150 millimeters. The calculated bar spacing is 101.4 millimeter, which is small than 150 millimeters, so it's safe. For the beam detailing, top view showed the arrangement of H16 and H8 bars for the longitudinal and shear reinforcement and ensures the proper placement for the structure integrity. For the cross-section, reinforcement includes 3H16 for tension and compression zone, and for proper spacing and detailing follow the safety requirements.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amruddin bin Nasaruddin. Okay, I will present about continuous beam that our group designing. Okay, this is our group continuous beam, which means beam A 1, to 4 in the first floor, beam D 2 to 4 ground floor, B 1 to 4 first floor, beam B 1 to 4 ground floor, and 2 C to E first floor. Okay, so designing a continuous beam involve detailed analysis and evaluation of structural behavior under various loading conditions to ensure strength and stability. So the key consideration include calculating the percentage of required tensile reinforcement, ensuring the reference reinforcement ratio adheres to standard, and adjusting the effective depth and spare ratio to meet design requirement.
Good morning, everyone. Today, I will explain the step-by-step process of designing a beam. The first step is to calculate the durability, fire resistance, and bond requirement for the beam. To determine the concrete cover, we consider an R60 fire resistance where the exit distance is 22 mm. Based on this, we calculate the nominal concrete cover, which gives us a value of 20 mm. The second step, we calculate the action on the slab. This particular beam carries three slabs, FS1, FS2, and FS3. The next step is involved calculating the loading for each span of the beam. For the first beam, we consider it as one short edge continuous. The second beam is modeled as two adjacent edge discontinuous. Finally, the third beam is one-way beam. The fourth step is to calculate the Gk and Qk value for each span. Gk represents the dead load, which include the safe weight of the beam and the additional load, such as weight of the brick wall. Qk represents the impulse or live load applied on the beam. The next step is the analysis of the beam. At the left figure show the example of analysis of the beam. At this step, we examine three different cases, each with distinct loading value. For each cases, we calculate the stiffness and the distribution factor for every span. This ensures a comprehensive understanding of how the beam performs under different loading conditions. Next, we provide an example calculation for case 1. First, we calculate the fixed end moment for this span, then analyze the distribution of the load of each span. Finally, we calculate the shear force for this beam. This process will be repeated for cases 2 and cases 3 to ensure consistency accuracy across all scenarios. Next is analyze shear force diagram and bending moment diagram. After obtaining all the value from the different cases, we proceed to analyze the shear force diagram and bending moment diagram for each span. The first figure illustrates the SFT and BMD for case 1, showcasing how the beam reacts under the specific loading condition of these cases. The second figure combines the result from all three cases, providing a comprehensive view of the beam behavior under different scenarios. These diagrams are essential for understanding the internal force and moment acting within the beam, which guide the design process to ensure safety and performance. Next, we proceed with the beam design reinforcement calculation. We begin by calculating the design bending moment, which is a key factor in determining how the beam will resist bending force. Next, we calculate the area of tension still required to handle this force. We also calculate the minimum and maximum reinforcement area to ensure the beam has sufficient strength and safety. After determining the required area of tension steel, we select two reinforced bars, each with a size of 16 mm to meet the design requirement. Finally, we repeat the beam design process for support 3 and span 3 to 4. However, for this section of the beam, we do not include the calculation of the minimum and maximum reinforcement area. This to ensure that we apply the same design principle while simplifying the process of the span. Next, we calculate the shear reinforcement for this beam, and here is example for support 1. First, we calculate the maximum shear force denoted as VRT maximum. Based on this, we determine the size of the shear link For this section, we select H6 spacing 200 shear links. Next, we calculate the minimum spacing for this link to ensure they are placed correctly for optimal strength. We also calculate the shear resistance of link Vmin and include the additional tensile force and longitudinal reinforcement to ensure the beam can safely resist shear force. Finally, we repeat this shear reinforcement calculation for support 2, support 3, and support 4. Each support is treated individually based on its specific loading and design requirement. This ensures that the shear reinforcement is accurately designed for each section of the beam.
Okay, this is some example calculation about deflection from for continuous beam A1 to 4 in the first floor. So in the deflection for each span, factors such as structural system constant which is K, modification factor for span less than 7 meters are provided. Uh, so the provided steel area are incorporated. So the deflection checks confirm the actual span to depth ratio remains within available limits. And so this calculation checks the limit which mean okay from the standard limit. Okay, next about calculation about cracking. So basically, we must check about for the all span for the cracking. So in the cracking, the allowable cracking which mean is 150 mm of cracking. So we must calculate and design our beam below than that. So that's all from me.
So, hi, Assalamualaikum and Salam Sejahtera. My name is Khairul Najwa binti Kamalazi and my matrix number is TF220132. So, I will explain my part, which is summary part and also conclusion part. So, for the summary, which is all the detailed design have been decided based on the calculation from the group members. So, for the first designer, which is Kalaivani, decide for the supported beam, which is F2 until 4, which is first floor beam. She designed the detailing of the beam, which is the top reinforcement is 3H8 and the bottom reinforcement itself is 3H60. Meanwhile, the continuous beam, she get the beam is A1 until 4, which is first floor beam. So the first section is the 2H16 for the bottom reinforcement, and next the middle section of the beam is 3H16. Meanwhile, the last section is 4H16. So moving on to the next designer, which is Nur Airil Danish bin Nur Azlan, which is for the simply supported beam. He designed for the A1 until 3 for the first floor beam. So the detailing that he get is 3H16 and for the top, and then the bottom is 3H20. Meanwhile, the continuous beam, he designed for the D2 until 4, which is ground floor beam. So the first cross section of the beam is on the top reinforcement is 4H12. Meanwhile, for the bottom reinforcement is 6H10, and then the middle cross section beam. So he designed for the he designed for the middle beam is 4H12, and then the last cross section is 2H12. So next we moving on to the next designer, which is Muhammad Nazrin bin Mustafa. So the simply supported beam that he designed is for E1 until 2, which is first floor beam. So the top reinforcement of the beam is 2H10, and then for the bottom reinforcement is 3H12. For the continuous beam that he designed for B1 until 4, first floor beam. So the first cross section of the beam is 3H12 for the bottom, and then the middle cross section, which is the bottom also, for that he get is 3H20, and then the last cross section of the beam is he get is 2H20. So next we're moving on to the next designer, which is Khairul Najwa, which is me. So the simply supported beam, I have to design for the F2 until 4, which is ground floor beam. So the top reinforcement that I designed is 3H10, and then the bottom is 2H20. Next, for the ground beam, so I designed for the B1 until 4, which is ground floor beam. So the first cross section that I get is the 7H12 for the bottom, and then the middle cross section of the beam is 7H12 also, and then the last cross section of the beam is I get is 6H12. So next, for the last designer is Ahmed Marwan Ibrahim, which is for the simply supported beam. He designed for E1 1 until 2, which is first floor. He get is the top of the beam is 7H16 and the bottom is 7H20. And then the lastly continuous beam, he designed for B1 until 4, which is first floor beam. So he designed for the first cross section is 2H6 on the bottom reinforcement, and then the middle cross section of the beam is he get 4H10 for the bottom reinforcement, and then the last cross section that he get is 6H8. So I think that's all for the summary part. So we're moving on to the next. Moving on to the conclusion. So to conclude all the projects, so the detailed design of the reinforcement concrete being based on the architecture plan. So its attention to the standard regulation. So by conducting a through this study, precise and accurate structural layout can be achieved. So adhering the Eurocode guideline to ensure the compliance with the standard while maintaining the structural safety, consider the both variable and permanent action. So the use of characteristic strength and appropriately sized reinforcement have been contributes to the structural sound and durable beam. So I think that's all for the conclusion part. So thank you for listening and watching our group presentation from group 2 video presentation. So thank you doctor for watching our video. Bye. Terima kasih.